So we were done with 2.1 and we're moving to 2.2, which is on linear relations and functions. Now, linear relations, right? Linear comes from the word for line, and so a linear relation would have a graph, which is a straight line, right? Linear equations, the way they look is they have no operations of variables other than addition, subtraction, or multiplication. So for example, you can do 4 times x, but not 4 divided by x, right? You could do x plus 4, x minus 4, but never divide by the x, okay? Never a square root of the x. Never a squaring or a cubing of the x. So you can take the x and you can just add, subtract, multiply by another number, and that's it. Okay? You can divide by a number, but you can't divide by x. Linear equations cannot have, they cannot have powers of variables other than 1, square roots of the variables, variables in the denominator, and so on. So, take a look at some cute little linear equations. 4x minus 5y equals 16. Both x and y are in the numerator. They don't have any exponents other than 1. Simple. X equals 10. Same situation. Here is another one. Negative 2/3 x minus 1 equals y. Y equals half x. Right? What are some examples of nonlinear? So here we have a y that's squared. Y is the next one nonlinear. Square root of x. How about the third one? Because you have x times y. And what about the fourth one? Because it's, yeah, you're dividing by x, right? Okay. So here, is A linear or not? Linear. So we'll just say yes. What about B? Yes. What about C? No, we got an x in the denominator. What about D? No. Okay? All right. So the growth rate of a sample of Bermuda grass is given by the function this. So this is a function that models the growth rate of this grass. And that means rate is how fast. Growth rate is how fast it grows, right? So how fast it grows. Now, this is important. F of x is the total height in inches, and then it's x days after an initial measurement. So x is the number of days, f of x is the total height. So in this, which would be the independent variable? X or f of x? X is the independent variable, and f of x is the dependent variable. And so that's what the first question is asking. The dependent variable is f of x, and what does it represent? Right, total height in inches. Height of grass in inches. Okay, do you notice how I have no pronouns in this? So for example, I don't say how much it grows, right? What's it? Right? You have to be very, very specific. Okay? And then the independent variable, right, is x. Correct. Number of days after the first measurement, right? And notice how that's in my own words, right? First measurement versus initial measurement. That's cool. That's good. That's great, right? You want to do that. You just don't want to change anything, and make it incorrect. So how tall is the sample after 3 days? Right? Right. So what are we given here? We're given what? X or f of x? We're given x equals 3. What do we want? Let's use function notation. We want f of 3. Okay? So f of 3 is 5.9 times 3 plus 3.25. 20.95. Do we second that? Yes? So f of 3 is 20.95. And are there units? Inches. So if I wanted to say in a sentence what this represents, f of 3 is 20.95 inches, what would I say? What would I say? To a height of 20.95 inches, right? So the sample is 20.95 inches after 3 days. All right. The term 3.25 in the function, right, in that function, this one, represents the height of the grass when it was initially measured. How many times taller is the sample after 3 days? We're going to divide, right? So 20.95 divided by 3.25. How much is that? How much? So, right. So it's about 6.5. So we're going to say 6.5 times bigger, taller. Okay. Times taller, sorry. Okay. All right. So let's talk about standard form. Equations can be put in different forms. Slope-intercept form, point-slope form, standard form. Standard form looks like this, ax plus by plus equals c, where a, b, and c are integers. So you cannot have, 3 over 2 times y. They must all be integers. Can integers be positive and negative? Yes. Right? Yes. And then ax and by are on the left side, and only the constant c is on the right side. Yes? Okay. We do this in Algebra 2, and I have to be very honest with you. Algebra 2 is one of the only places where you're asked to put an equation in standard form. And then, eventually it's point slope and slope intercept, and then calculus is more point slope. Okay? All right. So here's an example of an equation in standard form, right? Okay, so let's put this in standard form. So remember, we want x and y on the same side. Here, I'm going to subtract 4x. So we're going to have negative 4x plus 2y equals 5. And sometimes it's just as simple as that. All right. And the other one has all sorts of stuff happening, right? Yeah.
On the first one, could you also do it where you subtract 2y from one side and 5 from the other side? So it's negative.
You can. Yeah, so we normally do like x and then the y equals the constant. As long as you rearrange it afterwards, it's up to you. Okay? All right. Here. Okay. So first, I like to get rid of those fractions. All right? And the best way to get rid of denominators is multiply the whole equation through by the common denominator of all of the denominators. So between the 2 and the 3 and the 6, what would be the common denominator? 6. The least common denominator would be 6. So multiply this by 6, multiply this by 6, and this by 6, and this by 6. Even that 0, even that constant.
But we still multiply negative 1/5 by 6?
Everything. It's an equal opportunity multiplying. Otherwise, you're changing the problem. Okay?
Why we multiply by 6? I thought that you multiply everything else by 6, so we'll equal it.
No, you're going to multiply everything by 6 in order to get rid of all of the denominators.
Oh, okay.
Right. Okay, so here we're going to do a little bit of reducing. The 2 by the 6 gives us a 3. The 3 by the 6 gives us a 2. The 6 and the 6 will go away, and then that's a 0. So first off, we have 3 times 3, 9x, minus 4y, minus 1 equals 0. Well, the 6's went away. So then we're going to bring the 1 over to the other side, and we're going to get 9x minus 4y equal to 1. Okay? So we're not solving for anything. We're just rearranging and making it look like that. Okay. Intercepts.
Wait.
That's not, because standard form asks to be put in integers.
Oh, okay.
Mathematically, it's the same, but it's not, in the form just is defined that way. Okay, so in football or in any other sport, like if there is an interception, what happens? Somebody gets in the way of the path of the football, right? So somebody crosses the path of the football. So same situation here. When you intercept something, you get in the way. Or like when you're sending messages, secret messages, intercepting is getting in the way of. Intercepts in math are when a graph crosses the x or the y-axis. The point where it crosses the x-axis is called the x-intercept. And the point where it crosses the y-axis is called the y-intercept. So now, take a look at that x-intercept. What are the coordinates of that point? X equals 4, y equals 0, right? So if it's the x-intercept, there is a value in the x spot, and then there is a 0 in the other spot. Okay? X-intercept has a value in the x spot. What about the y-intercept? What's the coordinate of that one? 0, 6. So there is a value in the y spot and a 0 in the other spot. And this is how we're going to represent x-intercepts. All right? So always use coordinates. All right? Okay. Now, find the x-intercept and y-intercept of this. Okay? So, remember what we said. For x-intercept, there's always a 0 for the y, correct? So here's what we do.
Isn't it that the x can't be negative?
No, hang on. Let me finish a minute. So for the x-intercept, y is always going to be 0, right? So make or plug in 0 for y. So here's how it's going to work. You have negative 2x minus y minus 4 equals 0. Negative 2x minus 0 minus 4 equals 0. Okay? Well, no, because the y is going to go away. So let's continue with this and see what we're going to come up with. So negative 2x minus 4 equals 0. And now we're going to solve this for x. Negative 2x equals 4. And how much is x? Negative 2. We write it as -2, comma 0. Okay. For the y-intercept, plug in 0 for what this time? For x, right? If you want y-intercept, you want a number for y. So make x go away. So it'll be -2 times 0 minus y minus 4 equals 0. Here we have minus y minus 4 equals 0. Negative y equals 4. Y is -4. So we say 0, -4. So again, x-intercept has a number for x. Y-intercept has a number for y. All right? And then we're going to graph. It's the easiest thing to graph with x-intercept and y-intercept. We put in the x-intercept. We put in the y-intercept. And then you connect those points. Okay? So, whoa. Like that. Okay. Some people put arrows at the ends. I normally don't. Both ways, it implies they continue all the way. All right? Questions?
Oh, when we connect the points,
Okay, the homework for this. If there is any graphing involved, it must be done on graph paper. You must use a ruler for the x-axis, for the y-axis, and any other lines you're drawing. Okay? Now, let me actually finish the next page, and then I'll do a sample graph problem on graph paper, and I'll show you guys how I want you to do it. Yes?
what we're graphing on that homework, if you remember like 8 seconds, can you,
I will show you in the example. That's what I'm going to show you guys.
so if you do that for the homework, you just
Yeah, it's fine. Uh-huh.
Or are we also doing 2 point?
So Sharon is selling pies to make some extra money. She sells each apple pie for $3.75 and each peach pie for $4.25. Her goal is to make at least $183 in order to afford concert tickets. All right? Write an equation that models the different amounts of pie she needs to sell to meet her goal. All right? So she's selling apple pies and she's selling peach pies. So first I like to pick variables. X and Y are fine, but they can get a little too generic. How about if we use A for the apple and P for the peach pie? Right? So we want her to sell some apple pies at $3.75 each. So $3.75 times A is the number of apple pies, plus 4.25, that's the price for the peach pies, times P. And it says to write an equation, not an inequality, an equation. So we want that to equal 183. If it were an inequality and it said at least, what symbol would we have used for an inequality? Greater than or equal to. Because at least means 183 or more, right? So you want the money to be 183 or more. Okay, good. So now it says to graph the equation. Does it represent a function? Okay, so if I've got something like this, hold on. There are several ways to graph an equation. You can pick points. You can solve it for y and do y equals mx plus b. If it's something like this, my preferred method is x and y intercepts, because I could just make one of them 0 and I could just solve for the other variables. So let's graph using intercepts. All right. So first of all, make P equal to 0. So I have 3.75a plus 4.25 times 0 equal 183. 3.75a is 183. And then if I divide 183, how much? 48.8. Some. Yeah.
I'm like probably green remember, but we have to set each one equal to, but to get the grand total of 183, we're combining both the peach and apple pie.
Yeah.
But for the purpose of this problem, we're doing how many apple pies to get 183 and how many peach pies to get 183.
Right. Because those are the intercepts. So hang on, let's graph this and I will let you know. Yeah. Huh?
Oh, so on the SAT practice questions and stuff, they do a lot of questions like this, and they ask me how many peach pies and how many apple pies.
Mm-hmm. Yeah.
When we find the intercepts, does that mean anything?
I'll tell you. Yes.
Yeah,
yes. So first we're gonna make P equals 0, and then now we want to make A equals 0. So then we have 0 plus 4.25p is 183. And that means P is about 43. Okay. Now, the axes. I gave you a generic grid here, but we're going to modify this a little bit. So let's choose to call this one the A axis and this one the P. And now my numbers are in the 40s. That means, this is not going to do, which is okay. That means instead of going up by 1s, I can go up by 10s, right? So I can go up by 5s, I can go up by 3s, I can go up by 50s. Let's go up by 10s. That'll be easier. So this will make these 100 and then 80, 60, 40, 20, and so on. Well, I'm going to make each line 10 units, not 1. Okay? So now, the A intercept, right, is 49, 0. So 49, 0. And then the other one is 0, 43. All right. Now I'm going to draw a line to combine to connect these. Okay? Okay. What do the intercepts represent? How did we get the purple intercept, 49, 0? We made P equal to 0. So what does that mean? What does that mean? What does that intercept represent?
When A is 3 point.
So what was P? What was P? What did P stand for? What about the peach pies? How many peach pies you sold? So when you make that 0, if you sell 0 peach pies, how many apple pies should you sell to be able to afford $183 tickets? 49. So, okay. So this says must sell 49 apple if you sell 0 peaches. And then what does the p-intercept represent? That many if you sold 0 of the other. You see what you see? Isn't that cool? Like seriously, isn't that cool? Right? That's really pretty cool. This is how the graph mimics and dictates what you're going to do in real life. Yeah.
In the in-between section,
Uh-huh.
where in between that's like the minimum you can sell of each pie.
Right. So now let's pick any random point here. Let's pick this point. Okay? What are the coordinates of that point? 20, 30. That means you can get $183 if you sold 20 peach pies, 20 apple pies and 30 peach pies. Okay? So this means selling 20 apple and 30 peach. Or you could pick this point, right? That point is 30 and 10. You could do 30 apple and 10 peach. That would also work, right? Like that's so cool.
Yeah.
I mean, seriously, right? That's so awesome.
In those questions in the SAT,
Yeah.
just give you like options and pick which one.
You could. I mean, I could come up with like 53 questions on this. Like so many different ways to ask this. Okay? Yeah. Okay. If she sells 20 apple pies and 25 peach pies, will she meet her goal?
No.
Well, so there are a couple of ways you could do this, right? So 20 apple and 25 peach, you could do it by looking at the graph. 20 apple and 25 peach, you're here. You're not on the graph, right? You're under. So, right? So that's not going to work. Or you can plug it into the equation. So if A is 20, so 3.75 times 20, and then 4.25 times 25 equals how much? How much is that? 181. Not good enough. You're not going. Okay? Right? So you see how, you know, it's so similar. Okay. So I promised you I would show you a little bit about, you know, how to graph one of these. Sorry, how to do a graph on the homework. So here's some graph paper. And so what you're going to do is you're going to take a ruler, right? And you're going to draw yourself a cute little x-axis. And you're going to draw yourself a nice y-axis. And now, depending on the needs of your problem, this is too big, but like this is a huge graph. I'm just doing it this large in order to, you know, show you guys. Depending on the needs of your problem, you're going to calibrate the axis accordingly. So for example, if your numbers go from like 1 and 2 and 3 to like 20, 30, 40, don't go up by ones. Remember, you can calibrate this as you wish. So you can make this, for example, you know, you can make this 5, you can make this 10, you can make this 500, and then that becomes 1,000. You can do whatever you want. What you should not do is this. Oh no, it went away. What I see some students doing is this. You know, they'll do, for example, 5, and then 30, and then 50, and then 75, because those are the points that they're plotting. That's not correct. That's not right, because if one box here represents 5, then each of these boxes must represent 5. All right? So if you start with the 5, then these must go 10, 15, 20, and so on. It's okay to have that by 5s, but this by 2s. That's totally cool.
But what if they're not the same length?
No, they should be the same length. So you can do 2, 4, 6, but not 2, 5, 11, 14.
Like let's say your equation is 2, the x is 2 and the y is 22, and then the other one's -1.
So okay, so let me answer that question like this. Normally we have a different calibration when we're doing real life word problems. When you're graphing a problem such as y equals 57x plus 36, okay? In that case, calibrate them equally, right? So suppose you do have 57x plus 36, right? The y-intercept is 36 and the slope is 57. All right, let's make it like 55, okay? So that means you have to go up 55 and over 1. Oh my, right? So in that case, I would go up by like 20s, let's say. All right? So I would go like 20s there and then 20s here. Okay? Now, how do you show this? So let's see. All right, this so suppose you were going to graph y equals, we'll keep it simple, 3x plus 2. So we go 1, 2, 3 over 1. All right, so essentially, you know, okay, that needs to be done with a ruler. But essentially, that looks like it could be a correct graph. However, what's wrong with this? The arrows I'm okay with.
It's not straight.
Yeah, it's not straight. I mean, it has to be straight. But what I'm really not okay with, you should do it with a ruler, absolutely. What I'm not okay with is I don't know how these are calibrated, right? Yeah. So, and if you just do 1 and 1, that's still okay. But show me something. All right? We're cool? Okay. So, in that case, all right. So this homework will be due tomorrow, 9/27. We have class tomorrow.
No, I know, but
right, but you're not right. Tomorrow I'm gonna walk around and check that it's done. Okay. Now, tomorrow I'm gonna start teaching 2.3, and I'm gonna start 2.3 and 2.4. I might combine them. So because we do have an extended class tomorrow, okay? And it's slope and things, so we should be okay with them.